A little bit of a disclaimer, I think I exaggerated with the coffee. By default, I'm a speedy talker, but I'll try to pace myself. So now the title of our presentation today, Pick Your Poison. Usually people refer to this when dealing with multiple choices in which some unpleasant choices are involved. But for us, what I would like to showcase today is actually that these three fields are different sides of the same coin. And now in terms of our agenda, it's pretty straightforward and simple. It's going to be like a narrative. We're going to start by talking about history, first and foremost, to have a context, then about technicalities for each one of the fields, and last but not least, hopefully, by the end of it, you're going to understand the similarities and differences between these three fields, mainly reliability engineering, DevOps, and platform engineering. Now, a couple of words about me. My name is Alex. I'm a site reliability engineer at Systematic, and in my spare time, I'm an open source contributor, AWS community builder. That's my handle, so if you have any questions with regards to this presentation, feel free to reach me. Now, our starting point in today's presentation is the 12-factor app. How many of you have heard about 12-factor app? Please raise your hand. One? Okay, so these are the old geezers in the crowd. Now, this thing, 12-factor app, it's a pretty old framework, so to say. It originated in 2011 at Heroku. It was created by Adam Wiggins, and one important thing, this 12-factor app was created before container were established thing for packaging and managing our applications, right? Now, how it looks. As I said, it's basically a framework or, I don't know, a set of rules. It has a nice introduction, and if we scroll through it, first and foremost, it's for building web apps, right? This is at the pinnacle of software as a service. If you remember, we had that nice triangle with infrastructure as a service, platform as a service, and at the top, software as a service. And if we scroll through it and glance at it, we're going to see a couple of interesting things. First and foremost, who should read this document? Any developer building applications, ops engineer who deploy and manage those applications. So we're going to see some kind of alignment. And these are the rules. A couple of them, for example, dev prod parity, keep development, staging, and production as similar as possible. Other, like processes, execute app as one or more stateless processes. Some of the things from this list we are doing by default, so we are kind of spoiled. It's pretty obvious that we're going to have out of the get-go these kinds of things, but imagine at that point in time there was a need for someone to compile these kinds of requirements. Now we are looking here at the Stack Overflow trend chart, and we can clearly see, so Docker appeared in 2014. As we know, Docker was not the first containerization technology, but it was the one that really gained traction and made containers mainstream. And now, an interesting fact, if you're going today on Docker's site, you're going to see under Dockerfile best practices, a nice reference more exactly. This one referred to processes under 12-factor app methodology to get a feel for the motivation of running containers in a stateless fashion. Now, if you think about it, this translates in today's day and age in the fact that containers should have only one concern. That's why we have things like init containers, sidecar containers. So here we get the idea at the first glance that if you want to have something scalable, you have to have this mindset in when you're building your application, right, in a stateless fashion. Now, the second important thing, from my perspective, at the end of the day, shipping the software is the most important thing. Why? Because even if you have, I don't know, a cool application, a cool feature, if you don't deliver it to your users, it doesn't have any value, actually. So sometimes shipping the software might be somehow not very good practice for us. And now, as we established, Docker was very powerful containerization technology that hit the market. And if you take a look at the presentation from PyCon in 2014, when Solomon Hykes released Docker, he focused on shipping the software from A to B rather than the technical details of it, right, about the container engine, so on and so forth. And now the funny part is, if you think about it, in the 90s, a company called Sun Microsystems actually leveraged the same mentality, write once and run everywhere, if you know this catchphrase, of course with a small caveat about the JVM, so on and so forth. But now we can really see the value of packaging applications and make them portable, because this is the second idea in which we operate today. And now for me, I realized pretty late that there's no such thing as containers, right? So we are operating with these nice abstractions called containers. And I don't know, one of the definitions is that containers are just file system bundles that we unpack on our machines and pass it to a container runtime to run. And if you think about it, what's a container? More exactly, what's a container image? Because that's the important part for us. We need to have three things in our container image. We need to have our code base, our dependencies, and the runtime, right? If you have these three things, you're good to go. And of course, you have to version it. You're going to have a digest and optionally some tags. But for me, I discovered another interesting definition, which is a rather mouthful, that container images are an ordered collection of root file system changes and the corresponding execution parameters for use within a container runtime. How many of you have heard about the second definition? One. Cool. Nice. Then I have a small demo for you. Actually, it was a bet with one of my friends. We're going to start very, very simple. In having a very complex application, let me show you. This is our application. So basically, can you see it? The font is good enough for you? We are printing hello world to standard output. I didn't specify the shebang because I want to be very specific with our runtime. In our case, it's Python. Our nice application looks like this. And of course, to build a container image, we need a Docker file. And if we take a look at our Docker file, we can see a couple of things. First and foremost, I have my base image, which contains the runtime for me, some metadata. I'm copying the code base here. We don't have any dependencies, and here I establish how my container will start. And the next step for us is to build our image. I'm pretty bad with the namings, but I will choose, I don't know, yay, and we're going to pass the current directory as a build context. What will happen behind the scenes? Of course, our image will be built, and now we want to start a container based on our images, on our image. And for this, we're going to Docker run. We're not going to name our container. We're going to pass the image. And guess what we're going to have? Hello world. So this is the first step, pretty simple, pretty obvious, pretty straightforward. If we, I don't know, grab for our image, we can see a couple of things. First and foremost, it's yay, it's not yay. The name of the image, the default tag latest, because I didn't specify any other tag, and I had some layers cached there, and it's 4 days old, created 4 days. But now let's leverage Docker and do a Docker save. How many of you have used Docker save? No one? 1, 2, 3. Cool. For those who didn't use, it's a nice feature of Docker in which you can save your image as a tarball, right? So we're going to do exactly that. We're going to pass our image. We're going to specify the output, and maybe, I don't know, not test, let's choose another name, yay.tar. And now we're going to have this tarball on our machine. So no lie, it's here. Let's create a directory, I don't know, test, and we're going to, the next step, extract our tarball in the newly created directory. Now, if we cd there, we're going to see a couple of things. Some blobs directory, some other files like index and manifest, but we are interested in the manifest file. And if we pick at that one, hopefully it's just a JSON file. It has lots of interesting things, but for us, this is the meat, this is the core part. I'm going to take this up, and it looks kind of nasty, but that's no problem. I didn't lie with anything. This file is here in our directory. And now I'm interested in a couple of things. First and foremost, the entry point. So let's take a look at this one. And guess what? I would like to delete this. And here we can see that this is our entry point with Python. Now we have the CMD. Guess what? I'll want to use another binary, echo. Hopefully we have this one. And I don't know. Let's pass another string. And I will choose, hacked. Probably I'll do lots of typos. And now I have another bone to pick. I really don't like, I'm a millennial and I really don't like this year. Let's change it with 91. And guess what? Now what we have to do is to rebuild our tarball, right? So we're going to create, let's call it new, I don't know. This current directory. And here we have our new tarball. Next, let's remove the old image. We can still keep it, but just to keep it clean, right? Up. And now we're going to also leverage Docker and load the new tarball. And now we have once more our yay image with the tag latest, and now we're going to try it to run it once more. And guess what? We have another behavior for our container. It's not anymore hello world, and I didn't modify anything in terms of layers. I mean, if we do an ls inside the container, our script is still there. And another interesting thing, if we list the images and grep for yay, we can see it's 33 years old. And this doesn't make any sense. I mean, Docker is not that old. What I wanted to showcase you is that containers are more than a, I don't know, sandbox, and they're a powerful abstraction. Now, moving further with our presentation. Due to the fact that containers are such a powerful abstraction, now we can easily distribute, ship things, package them, and even more. That container image that we built, it can be run by other container runtimes like Podman, or if you're in Kubernetes. As we all know, Kubernetes doesn't really know how to run containers, and you're going to ship a container runtime like Containerd and run our image, and this is possible due to the OSA Open Container Initiative, which has these three specifications, meaning image spec, distribution spec, and runtime spec. I don't know if it's important for you to know them, but just hearing about them enhances the portability of containers. And now that we've seen this powerful abstraction, this opens up the landscape for the new perspective. Why? If I were to ask you, okay, what is a container image? Of course, it can be considered an artifact because we build it, we ship it, we distribute it in registries, but of course it can be an executable software bundle, because at the end of the day, we're going to pass that in a production environment, and we can inject vulnerabilities, we can have a large footprint with regards to resource consumption. So you can do really dumb things with containers, and last but not least, it can help you establish standards in your organization, because being so easy to use and having this plug and play mindset, it's easy to encompass technologies in your daily workflows. And let's take them one by one, every field. When talking about DevOps, the first search that I found is DevOps is a set of practices, tools, culture, or philosophy that automate and integrate the processes between software operations and development and operation. This is a mouthful. Yeah, it's a definition, not my kind of definition, but nonetheless, if you were to strip it down and think at the core of DevOps, it's all about automation, right? Because if you are doing a manual step, someone from DevOps team might tell you, I'm going to put that in a pipeline, don't type that. We have pipelines, we have processes for that. And this is a very healthy and good thing. Now, how many of you have seen this landscape? I have I don't know, something special with this one. I like to show it each time because, so this is Cloud Native Computing Foundation landscape, and all the technologies we are using or the technologies which are on a job description are here. So here we can find each small square. It's actually a technology that serves a purpose. Things we have here, things like Helm, Docker, Kubernetes, I don't know, Argo, Flux, so everything is here. If we take a deeper look, if you were to give me a number of how many technologies are here, who thinks that there are 100 technologies? 1,000? No, dude. What? No. That's too much. No, there are 200 technologies. So it's a pretty daunting landscape. And this looks like a market, actually. When you're going to start a new team, a new project, a new startup, you're going to go here and say, okay, I need for observability, maybe Prometheus, Jaeger, and I'm going to build my observability stack. And this brings in our discussion platform engineering teams, which the sole purpose of a platform engineering team, from my perspective, is to build toolchains and workflows that enable self-service for your team, project, organization, so on and so forth. Because as we've seen, that landscape is rather crazy. And now then, this begs the question, okay, how am I going to build a platform? The recipe is pretty simple. You're going to need a couple of stuff, the basis one, orchestrator, CI tool, CI/CD tool, something for security, maybe an identity provider, some registry to ship your images. Additionally, if you want, it's highly recommended to have some observability stuff, monitoring, logging. Nice to have a developer portal for your developers, and you can add how many things you would like on that list. Now I have a demo attempt. This one I'm not that sure that it's going to work. It was a bigger demo, but then I've seen the time slot and I also managed to use 15 minutes. Basically the gist of it, I'll try to build a platform in 5 minutes, and we're going to have an app, and I'm going to integrate two technologies, Argo CD for GitOps and Goldilocks for our resource consumption and utilization. But before that, let's start a little bit more slowly. Can you see my screen? So we're going to start with a simple app. I have a Docker Compose file. It looks like this, in which we have two services, a web app and a small Redis for caching. And if we spin them up, we're going to see how it looks exactly, our application. Now, the thing is, I'm reusing the same port. Hopefully, it's not going to be a problem. So it runs on 5000. And if we go here, localhost 5000, this is our nice app. It's a famous app that increments a counter each time we hit the index page. Cool, it works. So we are in a team. We started using containers. We started with Docker Compose. And someone says, no, we're using Kubernetes. Docker Compose is pretty old. We are not doing this now. Then we need to, first and foremost, I need to do a cleanup in here, as I said. This is a higher chance for me to mess the ports here. And you're going to say, yeah, no problem. I can translate this in Kubernetes objects, and I'm going to start to build my own manifest in here. And we're going to have the same application translated into Kubernetes in Kubernetes objects. And if we create those objects, simple objects, some deployments, some services, we have a little bit of storage there for some persistent volume claims and persistent volumes. If we take a look, these are our applications once more. Even more, if we take a look, we have some services as well. And now, due to the fact that we are in Kubernetes, now begs the question, okay, how I'm going to expose my application? Now we need to play a little bit with the services. We know that our application runs on port 5000, and I will create a service type of load balancer, which will expose our application on another port. Okay, and this one doesn't work, of course. And if we go here, we have our application once more, which works. The counter is resetted. Nice. But then again, there's another team, another project, and says, yo, Kubernetes is pretty old. You don't have values. We cannot do nothing fancy with it. And of course, let me clean up once more. We're going into the Helm side of things. And you're going to create a Helm chart. You're going to install your application. You're going to have releases. This is nice. It's very, very up to date, more or less. Our application is still here. It runs. The counter is resetted, so everything is fine and dandy. Now, of course, we need to clean up. And we've seen for the same app 3 different approaches. Now imagine that we need to add other capabilities like GitOps, like registries, like other things. And given our landscape picture, now you have to pick things up, right? And now we're going to have a platform team that will tell us, yo, we're not doing this shit. We're going to have you a platform for you, and you need to give us your repository. Now here, this is the heavy part. Basically, as we established, it's big enough for you? I will spin up a couple of components. Basically, behind the scenes, I'm installing Argo CD, Goldilocks, and tie everything together. And our platform team, as we established, it will ask for us a repository, right? And I already pushed the code in a repository just to pass it to the platform team. And they will ask for me, okay, give me your URL down there. I'll give that to them. And in a couple of minutes, hopefully, we're going to have an internal portal, a nice one if you ask me, with a couple of capabilities. So, let's try. Nice, so this is our internal portal, very fancy, but it has 2 nice features, FinOps and GitOps. For the GitOps part, we have, of course, Argo, I use self-signed certificates. That's why we have this. Whoop. And now we have our application embedded in Argo. I decided to opt out for automatic sync, therefore we need to manually sync it, meaning deploy it, up. These are our workloads. And even more, we have here a FinOps capability. Our application is integrated in Goldilocks by default. We are monitoring, we have some labels behind the scenes. We are monitoring the default namespace. And here you're going to see your applications. And guess what? It needs some time to collect some metrics. It uses VPA behind the scenes. But the nice part is that you can educate the project with regards to resource usage and things like request and limits. If we noticed by default we didn't specify any, I didn't specify any requests and limits for our workloads, but the platform team informs me, yo, you need to put some limits and requests for your workloads. Even more, it recommends some of them for me. Cool, so now we've seen the power of having a platform team. Now we need to touch upon the SRE side of things. This is the holy grail, the books with regards to site reliability engineering. I highly recommend maybe to glance at them. And the general idea when people think about reliability, it's a straight line with regards to availability, which is true most of the times, but also we have features like resource consumption, meaning efficiency, and last but not least, scalability, right? And all boils down to three things: the SLA, SLO, and SLI. Now, SRE in 1 minute. SLA, it's a contractual obligation. Usually C-level are there and some stakeholders. And this contract basically it's a stipulation. If you don't fulfill your promises, you're going to pay some penalties. We're not usually involved there, but we have the SLO, the target for our objective for a certain I don't know, subject. In our case, we are going to take availability because that's the simplest one. So here you're going to specify, okay, I would like for my application 100% availability. Then someone will tell you, no, this is not possible because there are other things that are not our own control. And we're going to establish, okay, the famous 4 nines, which are nice, 99.99% availability. So this is our target. And last but not least, we have the SLI, which is a concrete measurable way for us to see how far we are from our objective. And now a small exercise. So the management will come to us and says, okay, we need to establish an SLI for our objective, which is the availability over 1 month. And I heard it's easy to do. We like 99.9. And for us, we have a 10-node worker cluster, and our operation teams needs 100 minutes of downtime per month because they are deploying the application, I don't know, upgrading Kubernetes. We don't care about the reason, but we know we have 10 minutes per node of downtime amounting to 100 minutes, meaning almost 2 hours, right? 1 hour and 40 minutes. And the general formula for the indicator is the number of good events divided by the total number of events. Now for us, the total number of events are the minutes in a month. For a 30-day month, we're going to amount to 43,200 minutes. And then the good events, meaning the uptime minutes, we're going to subtract the downtime minutes. Damn, I said minutes too many times. Which amounts to, if we plug in the numbers, amounts to 99.768%. Please remember this number. This is our SLI, remember. We calculated, this is what we do, and guess what? The management will come to us and say, okay, we need to improve this, right? It's pretty simple. I want 4 nines. And you're going to say, yeah, of course we can do it. You're going to go to your colleagues in operation and say, we need to improve this. We need to cut down the downtime. And they will be, yeah, no problem. We can do this. So from 100 minutes, almost 2 hours, they will bring it down to under 1 hour and cut in half the downtime. Now, when you're going to operations, usually you're going to hear things like automate. And okay, I can cut down the downtime for you, but it will take like 3-4 weeks, maybe 2 months, because they are focusing on their bread and butter automating stuff. And at the end of 1 month, you're going to have a new number, 50 minutes of downtime. And if you crunch the numbers, this amounts to a staggering number of 99.8. So for a 0.1 decimal improvement, You work for 1 month, and then you're going to go to your management and say, yo, this is the best that we can do for the moment. So this shows you everything, how collapsed between operation, SRE, and platform engineering. And the general idea, if we were to funnel it, starting from dev to production, we're going to see in the beginning different projects, different teams that will going to pick their technology according to their solutions, right? Then you're going to have, if the organization is, I don't know, well equipped and has the knowledge to build a platform engineering team that will help you to streamline those technologies and build a platform for you. Of course, they can use already baked in technologies like Crossplane or Backstage. And as soon as we touch production, you're going to have your reliability team that needs to work in a proactive way and not in a reactive way. So it needs to be careful not have things like out of memory or not ready pods, and the reliability team needs to align with the platform engineering team with regards to observability stack, right? Because at the end for production you're going to need log traces and metrics. So this is the entire funnel, and as we can see, those teams are interlacing, crossing each other at certain stages, but also have different purposes in our organization. And last but not least, one takeaway that I would like to share with you, take this presentation with a grain of salt, because at the end of the day, everything is subjective, even the application. If somebody will ask you, what's the definition of an application? What's an application for you? It can be a binary in a VM, it can be a binary in a container, it can be a pod in Kubernetes, or why not multiple pods orchestrated by Kubernetes, or for the serverless junkies, a hosted DB and some Lambdas function. So this is very subjective when it comes to technology. And basically that was the entire presentation. Thank you very much for your time.
We have a few minutes for questions before lunch. Hand up. Who has questions? And a person with a microphone will come to you. Raise your hand up. Come on. There we go. One in front.
Hello, Alex. This is Marian. Based on your experience, what is the most useful tool in this world of DevOps, SRE, and platform engineering?
That's a good question. It's a famous question. If you can have, I don't know, things like platform engineering teams or DevOps without Kubernetes. My answer is that you can have without Kubernetes, you can orchestrate with it Docker, Swarm, or Mesos, but fortunately or unfortunately, Kubernetes is the most useful one, I would say.
It is the one, the most
prevalent technology, yeah. If you're going to any organization, most of the time you're going to have a Kubernetes flavor.
Your personal tool, which you like it most?
Porter, which I didn't talk about.
Thank you.
Welcome. Cool. Thank you very much. Poftă bună.
Okay, well, round of applause.